Section 5.1, Introduction to Matrices. Okay, so in this section, we're going to be talking about matrices. And so a rectangular array of numbers arranged in rows and columns is an example of a matrix. So that looks something like this. And the numbers inside of the matrix are called elements. And the order or size of a matrix is given by the number of rows and the number of columns. So another word for order would be size. If the number of rows and columns is the same, we say that we have a square matrix. And if you have this notation, A subscript ij, then this is just referring to a location of an element. And that location is going to be the ith row and j column. So in example 1, we're given this matrix. And so to determine the order of the matrix, we check to see how many rows does it have. So the rows are going across. So we have 1, 2, 3. And how many columns are going down. So we have 1, 2. So we say that the order of the matrix is a 3 by 2 matrix. Then we're asked to identify A12. The 1 represents the row and the 2 represents the column. So we go to our matrix here, we go to row 1, second column. So that number is going to be -2. Let's identify A31. So that means the third row, first column. So third row, first column. So third row, first column is going to be this one. Two matrices A and B are equal if and only if they have the same order and their corresponding entries are the same. So here I'm given three matrices. Let's figure out the order. So this is a 3 by 2. This is a 3 by 2 and a 3 by 2. So all the orders are the same. And the first one is A equal to B. So we have to compare A and B and make sure all the elements inside are the same. So we have a 5 and a 5, -2, -2, -3, -3, half, and 0.5, that's the same. 1 and 1, 6 and 6. So we say that this is true. A is equal to B. Is A equal to C? Here I have a 5 and a 3, so since 5 is not the same as 3, we say that this is false. A does not equal to C. Okay, so example 3, given that A equals B, and A is this matrix and B is this matrix, what is X, Y, and Z? So here they're telling us that the matrix for A and matrix B are equal to each other. So what that means is that the entries should be the same. So if I have a 1 here, then this has to be a 1. So that tells me that X is equal to 1. If I have a Z here and this is a 3, then that means that Z has to be 3. And now this Y plus 1 has to be equal to a 5. So I can set it up as Y plus 1 is equal to 5. So that means that Y is going to be equal to 4. We're interested in adding, subtracting the matrices. So to add, number 1, you have to have the same order, and then you add the corresponding entries. And to subtract, you would do the same. If you have a matrix with all zeros, we say that's a zero matrix, and that's the additive identity for matrices. So if I want to add these, I'm going to check the order just to make sure. The order is the same. So that means that we can add the corresponding entries. So I'm going to add -4 plus 6 is a 2. A 3 plus a -3 is 0. A 7 plus a 2 is 9. And 6 plus -4 is 2. And then here we have a 3 by 2 and a 3 by 2. So that's the same. So 5 minus a -4, that's going to be a +9. 4 minus 8 is a -4. -3 minus 6, -9. 7 minus 0 is 7. 0 minus -5 is +5. 1 minus 3 is -2. So that's one way to do this. Another way to do this is we can use scalar multiplication, which we'll see down here. But basically what that means is the subtraction, I would change it to addition, but this negative is going to be applied to every element in the matrix. So negative is a positive 4, negative times 8 is a negative 8, negative times 6 is a negative 6, 0, negative is positive 5, and negative 3. And so what that happens is you end up with addition, which makes it a lot easier. 5 plus 4 is 9, 4 plus negative 8 is negative 4, negative 3 plus negative 6 is negative 9, 7 plus 0 is 7, 0 plus 5 is 5, 1 plus negative 3 is negative 2. So what we did above is we multiplied by negative 1 to all the matrix. And when we do that, this is called scalar multiplication, which means that you're taking a number, multiplying the whole matrix by it. So here it says multiply negative 6 times b. So I'm going to write down b. And so we're just going to multiply everything by this negative 6. So negative 6 times negative 1, positive 6, negative 6 times negative 2, positive 12, negative 6 times 8, negative 48, negative 6 times 5, negative 30. Okay, the next one we have 3a plus 2 times b. Since we're adding, we have to make sure the order is the same, which it is. Okay, so I'm going to multiply the scalar in here. 3 times negative 4 is negative 12. 3 times 1 is 3. 3 times 3 is 9. 3 times 0 is 0. 2 times negative 1 is negative 2. 2 times negative 2 is negative 4. 2 times 8 is 16. 2 times 5 is 10. Negative 12 plus negative 2 is negative 14. 3 plus negative 4 is negative 1. 9 plus 16 is 25. 0 plus 10 is 10.